students, if I ask you this question, what is the probability of getting a 6 when you roll a die, right? It won't even take you a second to say 1 by 6, right? Because when you see the total number of sample space when you roll a die is 1, 2, 3, 4, 5, 6, and out of that your favorable event is only 6, which is just one of the cases. So the total number of favorable events divided by total number of sample space becomes your probability of getting a 6, which is going to be 1 by 6, right? Pretty easy. Now if I ask you this question, let's say me and my friend decide to meet at a coffee shop between 11 to 12 noon, right? But the condition is whoever arrives first will just wait for 20 minutes and after that he will leave. What are the probability that we both will meet given that our arrival times are completely random, right? So I'll repeat the question. We decide to meet between 11 to 12 noon at the coffee shop, and whoever reaches first will only wait for 20 minutes and then leave. So what is the probability that we both will meet at the coffee shop? Now to answer this question, this will take you back because you cannot count the sample space over here because there are infinitely so many times between 11 to 12 noon itself. It's like counting the real numbers between 11 to 12, right? There are infinitely many such real numbers, right? Because time can be broken down into very, very small units, okay? So in order to solve this problem, I will make use of something called geometrical probability, right? So I will consider two axes, let's say y-axis and x-axis. X-axis represents the time of my arrival to the coffee shop, and y-axis I will represent the time of arrival of my friend. Let's say the origin represents 11 AM. So I can arrive anytime between 11 to, let's say, 60 minutes past 11, right? So this is the duration in which I can arrive. So I can choose any real number line, any real number on this number line. Similarly, my friend can arrive anytime between 11 to 12. So there is a 60 minutes duration between 11 to 12. So the sample space here would be the square box which is created over here. So any point on the square box represents the x and the y coordinates, where x represents my time of arrival and y represents the time of arrival of my friend, right? Now here the favorable condition would be the graph represented by x minus y mod is less than 20, right? X minus y mod less than 20. Why x minus y mod less than 20? See, x is the time of my arrival, y is the time of arrival of my friend. So the difference in their time of arrivals, difference, remember we are talking about difference, so difference has to be represented by a mod. So the difference at the time of arrival of me and my friend has to be less than 20. So if you have already learned this in your class 11th, how to plot a linear inequation graph in two variables, you would realize that the graph would be represented by this streak that you see on the figure next to you, right? So the area of this streak divided by the area of the entire square box would give me the required probability. Now it's very simple to find that because it's simple geometry. So if you see these two triangles over here, subtract the area of the two triangles from the area of the square. So area of the square is going to be 3600 units, and the area of the two triangles would be half base into height, which is half 40 into 40, which makes you 800. And since there are two such triangles, that is 2 into 800, which is 1600. So subtract 3600 minus 1600, you will get 2000 as the required area of this strip. Now, so total probability that me and my friend meet at the coffee shop would be 2000 divided by 3600, which is going to be 5 by 9. Simple. So we solve this by using geometrical probability.